So when we talk about trigonometry, we're trying to solve problems that are in the real world. A lot of times people use the terms angle of depression or angle of elevation. So the angle of elevation is looking up and the angle of depression is looking down. So if you imagine somebody looking horizontally, that would be like 0 degrees. So just looking straight forward would be 0 degrees. If you turn your head to look up, that's angle of elevation. If you turn your head to look down, that's angle of depression. So let's say you have a boat and you have a bird, okay? The person in the boat is looking up, so that would be an angle of elevation, right? This is horizontal for the boat person, and they're looking up. The bird, horizontal would be over here, and they'd be looking down. So sometimes you're high up and you're looking down, or you're down at the bottom looking up. So angle of elevation is just turning your head to look up, and angle of depression is turning your head to look down. And you could have people looking at each other where one is looking up, one is looking down. And they would always tell you, the boat would be looking up, the bird would be looking down. And the reference is horizontal is 0 degrees, okay? So horizontal would be 0 degrees. And, obviously you don't do problems where the angle of the triangle is 0 degrees. But that's what it's in reference to. Okay, let's do this last problem. An inquisitive math student is standing 25 feet from the base of the Washington Monument. The angle of elevation from her horizontal line of sight is 87.4 degrees. Her eye height is 5 feet. So this student might be more than 5 feet tall, right? The difference between your height and your eye height are two different things. So draw a line that represents the Washington Monument. Draw this girl, and then draw a line connecting them. So I want you to draw another line from where her eyes are. I'm going to draw a dashed line. So her line of sight, if she was looking horizontal, would be looking at the base of the Washington Monument. It wouldn't be very high up. The thing is really tall. And then draw another dashed line at her looking at the top. Okay? So at one point, she's looking at the bottom. At one point, she's looking at the top. And so this angle is a right angle. Her distance from the Washington Monument is 25 feet. That's on the ground. So it's easy to measure things on the ground, right? You could say, how far am I from the Washington Monument on the ground? That you can measure. You have to measure something. You can't just look at it and not measure anything. So this is 25, but I'm going to write it in the triangle because these would be equal, right? This length down here and this length, 25. So the length on the ground is 25. That's this. Let me scoot that over a little bit. The angle of elevation is 87.4. So again, she's looking up. This is an amount of turn. So when she's looking horizontal, that's 0 degrees. She rotates her head up to look at the top of the Washington Monument. Now, you can do this with a protractor. You can do this with more scientific equipment. But a simple protractor like you used in grade school would measure that angle. Okay, you just look at it and rotate your head and just see what that degrees is, and you might estimate it. You might estimate it, but certainly you could use technology to get that more accurate. Now, I cannot find this one automatically. I'm looking at this one, so I'm gonna just shade this triangle in here so that you know what we're dealing with. That X has to do with that triangle. It's not the answer to our problem, okay? The answer to our problem will be easy to find once we find the X. So that's the height from her eye height to the top of the Washington Monument. This number is going to be really large. okay? The way I drew it, it might look like it's about equal to this, but this angle is about 2.5, and this angle is 87.5, so this number should be way bigger, okay, than 25, because that angle is much bigger. All right, so let's do some right triangle trigonometry. So I'm using the 87.5. Oops. I'm using the 87.5. You always got to pick the angle. Then the side I'm finding is the opposite. That's the unknown. I'm not going to use this side because I don't know this side either. There can't be two unknowns. So that's my only unknown that I can use. That means I must use the 25. That's the adjacent leg. And therefore, I'm using tangent. So tangent of 87.5. Tangent is TOA. It's the TOA part of SOHCAHTOA. Tangent is opposite over adjacent. Remember that sometimes you multiply, sometimes you divide. When the x is on the top, you're going to multiply. It comes from cross multiplying. 25 gets multiplied times this, x gets multiplied times 1. You type this in your calculator. That's not the final answer, but this is the start of this. And like I said, it's going to be a large number. 572.59 feet. That's the distance from here to here. The only issue is that our x goes from here to here. It doesn't include her height. So this little length right here is 5 because her eye height is 5. So all I do is add 5 to that. It's really simple to adjust it to be our answer. Sometimes we do problems directly off the ground. We just, normally wouldn't lay on the ground and measure the angle. But if you did lay on the ground and measure the angle, then it would avoid you having to add that 5 at the end. And that is the answer to that.